Okay, hello class. Weekly update 8. So you guys had started chapter 4 of journal 3, and it looked like for the most part, really nice job overall collectively as a class on these topics. So Riemann, double Riemann sums, just an extension of single Riemann sums, pretty straightforward and just a lot of tedious arithmetic. And then double integrals, you guys did a really nice job, and it looked like a overall working from the inside out of an integral, and you can even see triple integrals and further ones in maybe your physics and astrophysics classes. And you just keep doing that inside out property. So really nice job, and it looks like as a class you guys like to integrate. Okay, and then you also had the optimization from last week. You did part 2 this time. Okay, so a few general updates, then we'll get into some of the specific assignments. So the a couple errors folks noticed. So thank you, Clarissa and Griffin. Clarissa noticed in the journals on the Lagrange multiplier example, I made arithmetic error. So if any of you followed through with that example and like what's going on. But Clarissa emailed me, so bonus point to her. That will be corrected in future editions. And then Griffin noticed a sign change error in one of the CP review videos, so like 11 minutes in. So I'm going to update that for the future. So anytime you see these, sometimes you have to think of it as a service that you're helping future students. Okay, you got your midterm grades. Thanks to Chloe for doing all that grading, and very good collectively as a class. Lots of A's and B's. I hope we continue. I'd love to give all A's and B's at the end. Hasn't happened yet, but this could be the semester. And one thing I'm a little worried about is there's 3, 4, maybe 5 of you who I feel like your midterm grade, it's high, it's good, but I think you don't understand as much as that shows. So there might be a few of you got a B, and I'm not sure that that's really the level of your understanding. That's great because you've been diligent and persistent turning in all your assignments, but some of those assignments, maybe not complete thorough understanding. So we need to make some strategies for it. And I think you know who you are, those folks, because sometimes you make comments when you submit something and like, I didn't quite get this assignment, but here you go. It's time to start remedying those things, because all of this is working us towards the final exam where we're trying to get mastery by that final exam. All these assignments are meant for you to do that. You can go back at any time and resubmit anything. If you like, just make sure you email me and Chloe if you want to do that. Improve a grade at an earlier grade, or just show that you understand something. And I think the best way, if you're not sure if that midterm grade is accurate of your level of knowledge, a good way to check on that might be to simply take that midterm that was posted. It's time to print it out and just take a look at it, just see how you could do on those, because your final exam will be, so we've had lots of concept questions, so it'll be about half the questions are made up from concept, which are similar to your quiz questions and also similar to the chapter review at the end of every chapter. So great place to practice those, multiple choice. And then your final exam will also have a calculation portion, and that calculation portion is similar to your practice problems that are due, your calculation practice that are due every week, similar to that midterm. And there'll be problems very similar to the type that are on that midterm, but we'll add some more calculations that we're going to learn coming soon. So you want to prepare yourself for that and take a look at that midterm and see what you think now. It's time to allot yourself some time, 2 hours, and see how you can do, because we will have a timed final exam. During the final exam, allotted time, you can only have 2 hours. I'll tell you more about that as we get closer, but again, keep that in mind, as that is your ultimate goal, right? So these little assignments are all meant to build you towards that. And if you're one of those 3 or 4 people that I'm a little concerned about, let's make a plan. Let's figure out what we can do. There's lots of resources that you have on campus beyond me and Chloe, the math lab, and there's folks in your classes and in this class that you can reach out to. Okay. Oh yes, and on the calculation, so this was something that concerned me too. There's a couple of those folks that, again, maybe aren't understanding as much as their assignments grades might show, that are starting to rely a little too much on the tech tools. So the tech tools are there to help you check your work, but you still have to be able to do these by hand. On the final exam, you have to show your work. This is actually given to a committee that grades them, and so other colleagues in the math department. And in particular this time, during these COVID semesters, folks are really concerned about cheating, particularly in math and science classes where there are tools that make it easy. And so you have to show all your steps. So don't get too reliant on that, because if you just, turn an answer like 15 and then you got Wolfram Alpha, that's not going to do it for you. You got to show all your steps for the final. So let's keep that in mind as we're preparing throughout the class. Let's not make short-term goals. Let's make long-term goals on how we're going to learn this. But overall, I was super pleased to see these midterms, and then very pleased to see this week the level of understanding on this material was awesome. So for some of those things where people are having trouble with derivatives, it seems no problem with integrals. You did an excellent job this week. Okay, so let's think about, so the calculation. So there's just so many good ones this week. You'll see in the samples and examples I dumped, I don't know, there's probably 20 or 30 different assignments. So lots of shout outs to folks. So for the calculations, I really liked Will's and Griffin's, Mac, Patrick, Savannah, Aaron. Let's see, as usual, Grant and Clarissa did all the problems, Cameron as well. So check out their work. If there were some that you skipped that maybe you said, oh, this one looks a little tougher, I'll do the easier one. We'll go back and check what Grant, Cameron, and Clarissa did. And then the only person I noticed that did this, Keegan, used the separable property at least once in her calculation. So remember, that's if you can split all the x stuff times all the y stuff, you can actually split that into two integrals and just multiply those two. So she was able to do all the x stuff and all the y stuff. So sometimes that makes the work a bit easier. If you recognize that, or you start getting in the habit of recognizing, that's a great tool. Make your life easier. Okay, so nice job on that, Keegan. And let's see. Okay, so then we'll move on to the activities. Great, lots of great ones here. Let's see, I think I put Christie's in there, Griffin. Kelly had some really nice pictures of her work this time. Oh, the volume of a limb or body part was kind of interesting. Let's see. A couple of you were like, hey, I don't have a bathtub, which, yeah, that was just a Patrick placement. Like say you were doing your arm, you could find a container that you could shove your arm into. Some of the water goes out and you measure that volume. But he also had a nice discussion and visualization and step-by-step of how he could get the volume of the arm. I think Grace did this one, maybe Keegan as well. Griffin did it for his fingers, chopped them up in little segments, which Patrick said is kind of a Dexter thing to do, which is absolutely true. That reminded me of that show. Okay, then the coins. So a lot of you did that activity. Most of you did as a thought experiment because not too many of us have that many coins these days. However, Clarissa wins on that one. Clarissa has a ton of coins, as you'll see from her activity and her, maybe she's feeding a meter a lot. I liked Erin's assignment on these too, because each time she did them as a thought activity, and that's always possible with these activities. Sometimes you don't have the physical prop, but you can still think about doing it and write your step-by-step of, how you got to that final solution, your thought process, which Erin did wonderfully. I put those in there. She didn't have a banana. She didn't have enough coins. Dana made nice work. Again, check out her visualizations are beautiful as usual. And what I like on Cameron's assignment, and I think Savannah, but Cameron typically does this, and Savannah did it this time. Really nice, concise, excellent explanations where, you really, I think this is because Cameron's heading towards a teaching career. She's like, what is the point of this assignment? Why does Amy have this in here? What is she trying to make us get from this? And then once she understands that, she just sort of explains, like I gathered that the point of this, say the banana one or the coins, was to visually see that these Riemann sums are, and they can be improved as you make the size of the circular columns with the coins, or if you could turn this into rectangle, there's less space. So just trying to think on the other side, what is it meant to be gained from this assignment? Okay, then optimization, really fun. Again, this is a topic I love. I think I've mentioned this. I teach a undergrad graduate class. So if you guys continue and you want to take an elective, there's a 452, 451, 551 optimization class. It's all about that. It's really neat. It becomes visual. We'll go to much higher dimensional space. And so these optimization problems are a lower level version of that, and you got to see your thought process again. And it was really neat. Many of you mentioned that how, I think Christy mentioned, like how the part one assignment, you were able to use that to check your part 2 calculations. Like you listed the pros and cons and came out with the value of doing all these calculations, doing it in a very systematic way. Oh, I forgot to mention last week, and I apologize to Griffin on this. For his part 1 last week, I think I put it in the samples and examples from last week. He had a really wild outside the box thinking on his part 1s. He was using he did something with an umbrella and distances to the sort of sections of planes around the umbrella, and got ideas that would help him with this one. And then another one he used that was really interesting, and they're saying before, was if you could point a laser and get the travel time of the laser from the origin to the plane at different points on the plane, that would be a way to approximate as well. Okay, so then back to this time, part 2. I promise you that calculating a problem like this will be on the final exam. So you'll probably have maybe 12 calculation problems on the final exam, because again, we have a time restriction. This will be one of them. It'll be it'll be an optimization problem with a distance from a point to a surface. And let's see, many of you mentioned how last week, like I think Kelly had a really good jump on this last week with her part 1. So this time, and then she was able to talk about how maybe a small arithmetic error she made, but she noticed it this time. Let's see, many of you did it with a CP approach. So this was like Thomas and Mac had really good strategy, but maybe got off on some of the arithmetic errors. But Aaron and Dana May did the same approach, and so check theirs because they went through and didn't have those arithmetic errors. Very nice layout of the steps to do it if you did the CP D-test approach. The other way to do it was the Lagrange multipliers, and it'd be nice if you did one or the other to compare, see the pros and cons. And I think in this particular problem, the Lagrange multiplier approach was probably a little bit cleaner and simpler. And so check out, in particular, Clarissa or Grant's work there, very clearly laid out, and they just show you how simple it was to solve that system for this particular problem. But you, again, still had some fractions, or if you turned them into decimals, and I think that was where it caused some of the arithmetic errors. Some of you caught that with your part 1 work and said, like, this doesn't quite make sense, or it was hard to see. Maybe your arithmetic error made the point look like it was closest, but it really should have been just a little bit over. Okay, what else? Who else am I? Don't want to miss anybody else. Okay, so the Lagrange group was Griffin, Keegan, Kelly, and again, I think Clarissa and Grant's were probably the cleanest. Keegan had a really nice discussion of her pros and cons of the different methods. Grace also had a nice discussion, and one thing I really liked that Grace did this week is she collaborated with someone who she knew had done it well last week, and so she could understand the calculation parts. And great job. Please do that all throughout the semester. Like, use your lifelines in this class, and a great lifeline, at least your teammates or non-teammates that are also taking this class. They're happy to help. And then Eleanor had an approach that had some properties of, it wasn't quite CPs, it wasn't quite Lagrange multiplier, but it had some properties. So that was an interesting one. Take a look at hers. Okay, I think those are all my comments for this. So I guess the main thing is you guys are finishing, we're finishing book 3 now. So you're in the last little stretch of this chapter, and then we'll be ready to move on to some really exciting stuff also in book 3.5. So finish up with the double integrals this time. So you did great on great on the Riemann sums, and we're doing the last little section is other ways to do double integrals, and you can use them also to find areas. And then you've got your challenge problem. All right, well, have fun this week, and great job on this week's assignments.